From the beginning to the end of the road that leads to our school, I've noticed that there are lots of plastic accumulating around this area. So let's go see. Disrupt the health of the ecosystem. It releases toxic chemicals into the soil and water.
Approximately 8.3 billion metric tons of plastic has been produced worldwide, of which 6.3 billion metric tons has become plastic waste. Recycling is one of the methods which is used to dispose of waste plastic. But actually, only about 9% of plastic are recycled. Our project is degrading plastic by using Galleria and Zophobas morio.
First off, what is plastic? There are many types of plastic, but in this experiment, the insects were used to biodegrade polyethylene, HDPE, a high-density polyethylene, and polystyrene. The binary unit of polyethylene is ethylene glycol, and through polymerization, it turns into a polyethylene. And polyethylene makes up substances that is used in everyday life basis, such as plastic bags. The minor unit of polystyrene is styrene, and through polymerization, it turns into polystyrene. Polystyrene makes up substances that is used in everyday life basis, such as styrofoam and styrofoam boxes.
In this experiment, there were two species that involved. First is Galleria melonella, which have ability to biodegrade polyethylene
The
plastic.
strain Bacillus YP1 is able to depolymerize long-chain macromolecules of polyethylene into water-soluble low-molecular product. And Enterobacter aspergillus were chemically transforming plastic into a smaller unit of plastic, which is ethylene glycol.
Second is Zophobas morio, which have ability to biodegrade polystyrene.
Special ability to biodegrade styrofoam is because of the bacteria within them. It's the Exogorobacterium sp strain YT2. It originates from the Bacillus family and converts styrofoam into carbon dioxide, fecula, and biomass. The reason we use this insect is because, one, they're commonly found in our country, in many markets around the city, and two, because of their ability. They're able to biodegrade plastic and styrofoam.
Take care.
They're invertebrates, and so they don't feel pain from eating plastic or styrofoam.
The insect reproduce at a very fast rate of 500 eggs per reproductive cycle. So, this is our research question. What is the effect of different mixture of polyethylene and polystyrene waste upon the consumption rate of Zophobas morio and Galleria melonella? This is our hypothesis. Is it hypothesized that different mixture of polyethylene and polystyrene will affect the consumption rate of this species? The mixture with the highest consumption rate will be 100% of pure polystyrene styrofoam consumed by Zophobas morio.
The first step is to prepare plastic containers for live specimen of Zophobas morio and Galleria melonella, and these should be suitable for a live specimen and contains air hole. For the second step, prepare the mixture for the feeding, including 1. 100 polystyrene foam, 2. 100 polyethylene bag, 3. 60% polyethylene bags and 40% rice bran, 4. 60% polystyrene foam and 40% rice bran, and 5. 50% polyethylene bags and 50% polystyrene foam. Pack them inside a beaker and measure them using a scientific scale. Measurements of the initial mass should be measured precisely. Step 3. Add one of the mixture into the container containing Zophobas morio and Galleria melonella and wait for 24 hours. Step 4. After 24 hours, remove the mixture from the container as well as the waste product, ethylene glycol. In step 5, measure the final mass of the mixture using a scientific scale. The last step is to repeat the experiment 10 times.
This is our result. As we can see that the highest consumption rate of Zophobas morio is 100% of polystyrene, and the highest consumption rate of Galleria melonella is 50% of polyethylene and 50% of polystyrene. So, This is our conclusion. We found out that our result is met with our initial hypothesis. Each mixture had different consumption rate, with 100% of polystyrene mixture as the mixture with the highest consumption rate. To get the highest consumption rate and waste loss of the plastic, it is recommended not to put any food stuff into the feeding.
All of the species were able to distinguish between their foodstuff and plastic. This provides us an evidence that it won't be necessarily needed to separate polystyrene and polyethylene from source of waste.
It is hoped that this experiment could be a new alternative to the dumping of plastics in landfill sites. The future adaptation of this experiment could be using the bacteria within the insect itself. By using the bacteria, we can grow them on polyethylene film and polystyrene film and measure the weight loss. ขอบคุณค่ะ Bye.